All right, guys, now we are going to part B, verify trig identities. Now, a little of this has to, kind of depends on practice, familiarity with the stuff, okay? A lot of that goes a long way with intuition, okay? So check this out. Let me give you one to start off with. Okay, we have the secant squared of theta minus 1 over the secant squared theta, okay? And that supposedly equals the sine squared theta, okay? Supposedly, I don't know. We'll find out if it does, okay? So now let me show you what I do to attack this, okay? This guy right here, that's pretty simplified, okay? So I should be focusing on this side of the equation, okay? And typically that's how you're supposed to. You're supposed to just focus on one side. Every now and then, I'm not gonna lie, I cheat and I work on both sides simultaneously until I get to the same simplification. That's only sometimes when I'm just having a hard time with a problem, okay? But something like this, that should stand out to you. Let me show you. Notice the numerator says secant squared theta minus 1. Look up at these Pythagorean identities. You see one that has the secant squared theta? Look at this right here, secant squared theta. If I subtract this 1 to the other side, I get secant squared theta minus 1 equals tangent squared theta. Aha. Interesting. So this guy in the numerator is tangent squared theta. So I have tangent squared theta divided by secant squared theta. All right, looks good because now I have a fraction. Watch what I do. Tangent is sine over cosine, right? So tangent squared is sine squared over cosine squared. So this is sine squared theta over cosine squared theta. That's the tangent part. The secant, remember, that is the reciprocal of the cosine. So if it's secant squared, that's the reciprocal of the cosine squared theta. And you put that in the numerator, okay? Look what happens. Cancel, cancel. I'm left with sine squared theta. That's what it equals. Okay? So a lot of this is kind of like a puzzle. Okay? A lot of it is like a puzzle. Now, when I was talking about just having experience with this stuff, I'm going to show you one that probably you might not have figured out if you didn't know a trick. Okay? So watch this. Let me write this guy down. Okay, trying to try something. Oh yeah, okay. All right, so check this out. This guy right here, you're gonna need to know a trick. So we have secant of theta. So the secant of theta plus the tangent of theta. And that supposedly equals the cosine theta over 1 minus the sine of theta. All right. Okay, now which one looks nicer? I think that one looks nicer, okay? This one right here doesn't look as nice because you got a fraction right there, okay? So I'm going to focus on the fraction. I always think that if you mess with the fraction to try to turn it into something like that, that's just, this actually does look a little more simple, okay? Even though I know this is 1 over cosine, and I know that is sine over cosine, okay? I think I'm going to work with this. Now, I'm going to show you the secret. Okay, there's a trick to this. Remember the term conjugate, multiplying by the conjugate? Remember if I had something like 1 over 3 minus I, what would I have to do to simplify this denominator? I would have to multiply by the conjugate, right? So 3 plus I, 3 plus I. Okay, it was something you learned with complex numbers. We're going to do the same thing here. Okay, so watch this. I have the cosine of theta over 1 minus the sine of theta. Sorry, my writing gets sloppy. Okay, I'm going to multiply by the conjugate. 1 plus sine of theta, 1 plus sine of theta. Okay, you with me? That's the conjugate. And you do this whenever you see a 1 minus a trig function in a denominator. And watch what happens. I have a fraction. Okay, let's do the numerator. That's cosine of theta times 1. That's cosine of theta plus cosine sine. So cosine theta, sine theta. Okay. 1 times 1 is 1. okay? 1 times sine theta, that's sine theta, minus sine theta times 1, that's minus sine theta. They cancel. And then it's negative sine theta times positive sine theta. That's negative sine squared theta, right? Sine times sine is sine squared. Okay. All right, now let's look at our identities, right? Look what we have. We have 1 minus the sine squared theta, right? Look where I'm looking. 1 minus the sine squared theta. Look at this guy right here. If I subtract the sine squared theta off to the other side, I have 1 minus sine squared theta. What's it equal? Cosine squared theta. Okay, so making some progress. We're getting somewhere. So this guy in the denominator is equal to the cosine squared theta, which is awesome because look at my numerator. It's got all kinds of cosines in it. Cosine theta plus cosine theta sine theta. Okay. All right. Notice the numerator. Can't I factor out a cosine theta? Okay. So in the numerator, I have the cosine theta. I'm factoring it out to the front. And I guess I could have just left it like this. I don't know. But watch this. I'm going to factor that guy out. And I have 1 plus the sine of theta, okay, over cosine squared theta. Okay. And these guys will cancel, okay? So these cancel. I'm sorry, I shouldn't have canceled that whole thing. I meant to just cancel the 2. Okay. So the left with cosine of theta. All right, so now I'm going to head over to this direction. So now look what I have. I have 1 plus the sine of theta over the cosine of theta. Okay. Watch what happens. I'm going to split it into 2 fractions. I'm going to split that into 2 fractions. That's 1 over cosine theta plus sine over cosine theta. All right. What is 1 over the cosine of theta? Remember, 1 over the cosine of theta equals secant of theta. Oh, so that guy equals the secant of theta. Plus, what's sine of theta over cosine theta? Tangent of theta. Oh, look at this. Look at this. That's what we were trying to get. All right, just running around in circles. Okay, we started here, went through all this, and up to here. Okay, well, I hope you're not getting overwhelmed. I hope you're thinking more of this as like a fun puzzle or a challenge. If you need any help, you know where to find me. Love you guys. Bye.